Hello everyone, welcome to Physics Analysis YouTube channel. Today we shall discuss electrostatic lecture number 7, that is Coulomb's law. So let us start Coulomb's law. Charles Augustin D. Coulomb 1736 yes to 186, right? Charles Augustin D. Coulomb 1736 to 186. Charles Augustin, full name D. Coulomb, invented torsion balance. French physicist Charles invented torsion balance and used it to find out the force of interaction between small charges. So बच्चों remember Charles Funk 1736 born year, 186 death year, right? 1736 to 186. French physicist Charles Funk invented a torsion balance. What is torsion balance? This one you can see further in detail description box. Torsion balance जो है and used it to find out the force of interaction between small charges. Now according to Coulomb's law, the force of interaction, right? The force of interaction between any two point charge, right, is directly proportional to the product of charges and inversely proportional to this force acts always along the line joining the charges, right? So this is the statement of Coulomb's law. But remember here two words are, that means Coulomb's law also obey inverse square law, right? And what is this point charge? See, point charge I am writing here, point charge. So what is point charge? When the linear size of charged bodies, right, are much smaller than the distance separating the charges, right? So then the charged body are considered to be a point charge. listen everyone, this Coulomb's law जो है ना is valid in small charges only, and the charge must be at rest. So what is the clear cut जो है statement of Coulomb's law? The force of interaction acting in between any 2 point charge, which is actually when the small point charge means when the जो है linear size of charged body are much smaller as compared to the distance separating them. So we can consider it a point charge. So I repeat, the force of interaction between any 2 point charge is directly proportional to the product of their charges and inversely proportional to square of distance of separation. Always do remember, this force always act along the line joining the charges, right? So let us suppose 2 point charge. Let us suppose 2 point charge Q1 and Q2 are separated in vacuum. We will consider in medium also later. Now 2 point charges जो है Q1 and Q2 are separated in vacuum, a distance r, right? So let us suppose a 2 point charge here. This one is Q1 and this one is Q2. Both are separated in air and separated by a distance r. Okay, so let me consider this 2 point charge जो है are of same kind, same nature. Q1 is positive, Q2 is also positive, or else Q1 is negative or Q1 both negative or both positive, same kind. Then what will happen? There will be, let us consider F12 is the force acting on Q1 and F21 with the force acting on second charge. And suppose 2 point charge जो है are there, Q1 and Q2. Both are of opposite kind of nature. Distance between them is r. Then the force acting between these two will be force 1, 2, and this here जो है force 2, 1. Right? Let us consider 2 point charge Q1 and Q2 are separated in vacuum by a distance r. Then according to Coulomb's law, force is proportional to Q1 into Q2. Q2 magnitude of the product of magnitude of charge, that is F is proportional to Q1 into Q2. Also F is inversely proportional to distance of separation. If if R is the distance of separation, then the force acting between these two will be inversely proportional to R square. Combining these two, what I can write? Listen. Listen everyone, let us suppose that the 2 point charge Q1 and Q2 are separated by r distance in vacuum, right? We have considered 2 point charge separated in vacuum by a distance r. Then according to Coulomb's law, F is proportional to Q1 and Q2 and F is inversely proportional to r square. Combining these two, what I can write? F is proportional to Q1 into Q2 upon r square. Now to remove this sign of proportionality, we need to put here one constant. That constant जो है is equal to k, small k, yes, Q1 into Q2 upon r square. So this is the expression for, or what you call formula for electrostatics force. F is equal to K Q1 Q2 upon R square, where Q1 is the charge of 1, where Q1 and Q2 are the product of charges, and R square is the square of distance of separation. So F is equal to K into Q1 into Q2 by R square. This relation, this expression is for static force. Now here what I can write, where K is equal to constant of proportionality, where K is equal to constant of proportionality. Always remember everyone, where K is equal to constant of proportionality, and is also known as Coulomb's constant. Coulomb's constant or electrostatic force constant. Electrostatic force constant, right? Here one more thing I would like to add, that is the value of K. Remember everyone, the value of K जो है ना, the value of K depends on number one, nature of medium separating charges. Number two, system of unit. So if you do consider Q1 and Q2 2-point charge separated by R distance in vacuum, then according to Coulomb's law I can write F, what the force of interaction. Of course magnitude of force will be equal. What the force of interaction acting in between these two is directly proportional to the product of their charges. That is, F is proportional to Q1 and to Q2, and inversely proportional to square of distance of separation. That is, if the distance of separation is R, then the F will be written as F is inversely proportional to R square. F is proportional to Q1 into Q2 by R square. This is combining these two I can write. So F is equal to K into Q1 into Q2 by R square, where K is what? Where K is constant of proportionality and is also known as Coulomb's constant. Remember everyone, Coulomb's constant, which is also known as electrostatic force constant. And the value of K, of course the value of K depends upon nature of medium separating charges. Suppose these two charges, so here now we have considered to be in vacuum, but what if both of them are in water? What if placed in any of the medium, right? Now see the twist in Coulomb's law. When this 2-point charge जो है ना, when the 2-point charge जो है are situated in free space, you can write vacuum or air also. Then what happened in CGS system, in CGS unit, K value will come to 1, right? K is equal to 1. But in SI unit, K is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square. This is the value of K, and we write for K is equal to 1 upon 4 pi epsilon naught. Now what is there here? Epsilon naught. So I can write here where epsilon naught is equal to absolute electrical permittivity, right? Absolute electrical permittivity of free space. Both the point charge are placed in free space now, right? So this is very important, everyone. Kindly note it down. In CGS unit जो है k is equal to 1, but in SI k is equal to 9 into 10 raised to 9 Newton square per coulomb square. Now here is the equation. So thus what I can write, electrostatic force F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square. So suppose 2 point charge जो है are placed in air or in vacuum or in free space, right, separated by r distance. So what is the force of what is the coulomb force acting between these 2 point charge? That will be equal to 1 by 4 pi epsilon naught Q1 to go to by r square, where epsilon naught is what? So absolute electrical permittivity of free space or vacuum or air. Clear? Now let us discuss what is the unit and value of this epsilon naught. So I can rub it. Now value and unit of epsilon naught. Value and unit of, note it down everyone, value and unit of epsilon naught, right? So for that what we have F is equal to 1 by 4 pi epsilon naught into Q1 into Q2 by R square. We are having this one. So from here you can take epsilon naught is equal to 1 by 4 pi F, right, Q1 into Q2 by R square. So here what you can write, F, for F so you can write Newton, R square meter square, for F Newton, R square meter square, Q1 into Q2, so coulomb into coulomb. So what we are having, coulomb square Newton meter square. So I can write coulomb square per Newton per meter square. So this is the unit of epsilon naught. Also dimensional unit, also find out. Dimensional unit of epsilon naught is equal to, take from here cc 80, right, and Newton, so m l t to the power minus 2, right, and meter square, so l square. So what we are having, m की power minus 1, m to the power minus 1, l 1, 3 l to the power minus 3, t minus 2 goes up, t to the power 4 plus minus 2 है ना, plus, and what left, m to the power minus 1, l to the power minus 3, t to the power 4, and a square finally. So this is the dimensional unit of epsilon naught, and this is the unit of epsilon naught, SI unit of epsilon naught. This is the dimensional unit of epsilon naught. Now value. How to find out the value of epsilon naught? Here only I can find out, right? Value of epsilon naught. See, also बच्चों k is equal to 1 by 4 pi epsilon naught, you know na, k is equal to 1 by 4 pi epsilon naught. So from here epsilon naught you can take, epsilon naught is equal to 1 by 4 pi k, right, and this one, this value you know, 4 into 3.14 into 9 into 10 to the power 9 Newton meter square per coulomb square. So what is the value come? If you will solve this one, this value, the whole value, then the value will be 8.85 into 10 to the power minus 12 पर न्यूटन, यानी कि कूलम स्क्वायर पर कूलम, तो कूलम स्क्वायर पर न्यूटन पर मीटर स्क्वायर. This is the value of epsilon naught. So you can find out the value of epsilon naught using k is equal to 1 by 4 pi epsilon naught. Okay, so of k here you can write 4 into 3, 1 upon 4 into 3.14 into 10 into 9 into 10 raised to 9 Newton square per coulomb square. That means coulomb will go up, and then here it is coulomb square per Newton per meter square. 8.85 into 10 raised to minus 12. This is the value of epsilon naught. What is epsilon naught? Absolute electrical permittivity of free space, right? And this is the dimensional unit, and this is the SI unit. SI unit, dimensional unit, and this is the value of epsilon naught. So I hope it is clear, everyone. So let me rub this one. Okay, dear student, now we shall discuss Coulomb's law in vector form. Very important topic. Coulomb's law. Coulomb's law in vector form. Achha, dear student, vector form means what? Showing direction also. So if we consider 2-point charge, this is how giving position vector. If we do consider 2-point charge Q1 and Q2, this is how 2-point charge are placed in vacuum, giving position vector R1 for Q1 and R2 for Q2, right? And the distance between these two, if you do consider R12, if we go along 1 to 2 and R21 going along 2 to 1, right? Then what is the force acting on Q2 because of Q1? If both जो है are of same kind, here I am writing AB, right, for convenient purpose. Along this way, F21, and here जो है because of 2, the force will be F12. Let R1 is equal to position vector of Q1 and R2 जो है is equal to position vector of Q2. Okay, then what I can write, students, using triangle law. Using triangle law, so from the triangle R1 R21 is equal to R2, so R1 plus R12 is equal to R2, this one, this is how it goes, right? So R12 is equal to R2 minus R1. Similarly, I can write in this situation R2 plus R21 is equal to R1. So R21 is equal to R1 minus R2. Looking these two, clearly I can write R12 is equal to minus of R21. right? R12 is equal to minus of R21 or R21 is equal to minus of R12. F12, okay na, be the force acting on Q1, okay, due to Q2, and F21 be the force acting on Q2 due to Q1. Then F12 means force acting on 1 because of 2. So I will take direction this way. F12 is equal to, remember both the charges are placed in vacuum, air or free space. Vacuum, air, free space. Don't be confused, dear students, right? So I will write F12 is equal to 1 by 4 pi epsilon naught for vacuum, air or free space, and Q1 of course Q2 by R square. R means direction, the distance between these two, and we are talking about F12. F12 means what? Force acting on 1 because of 2. Taking this direction, so this direction R21, right? R21 the whole square. But remember this one, R21, if we say na, this one will be mod. Because see, we are taking the distance between these two. But if I am writing force in vector, 1, 1, 2 is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by 4 to 1. This one, 4 to 1, this direction. Taking mode 4 to 1 square along BA. This is B and A, BA. Understood? Showing direction, this is the vector form, or else what? Yes na? So I can write F is equal to 1 by 4 pi epsilon naught Q1 into Q2 by, this one I am writing in magnitude only, so I can write R21 only square, and this one is along BA. So along BA, taking direction R21 cap. Clear everyone? Now for R21, what I can write? 1 upon 4 pi epsilon naught into Q1 into Q2 by R21 square. See how to find out unit vector R21 जो है will be equal to R21 vector divided by R21 की magnitude, this only you know na. So R here I can write R21 and in place of R21 divided by R21 mod, so here I can write cube. So this is the vector form of Coulomb's law. F12, this one, F12 this one, F12 equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R21 whole cube, R21 vector, right? Note it down everyone, note it down. I will rub this one. Okay, I am rubbing this one now. See, okay. Now see, also for F21 also for same. Now do the same for F21 for this Q2 charge. So for F21 I will write F21 means force acting on second charge because of first charge, right? So of course taking direction in this way, so is equal to F21 is equal to 1 by 4 pi epsilon naught into Q1 into Q2 upon R square. Taking direction, this is how. So R12 I will write, okay, is of course mod along AB बच्चों. What? This is the vector form showing magnitude as well as direction. This is the vector format. You can simplify more. 1 by 4 pi epsilon naught into Q1 into Q2 by R12. Mod square means I will write only R12 square. Okay. Along AB means R12 cap. Right now. And now remove this this unit vector. So 1 by 4 pi epsilon naught Q1 into Q2 by R12 square. Removing this unit vector, I will write R12 vector and here will be cube. In place of square, here will be cube. Why? Because R12 unit vector is equal to, can be written as R12 vector by R12 in mod. So one coming here, R12 cap, R12 cube. So finally, this one is the 1 by 4 pi epsilon naught into Q1 into Q2 by R12 cube R12 vector. So this is how you can write. Now one thing is very common. Listen, R12 and here it is R21. Rest everything is same. See, 1 by 4 pi epsilon naught Q1 into Q2 by R12 or R21. No matter. Actually this is magnitude only, na? So these two are same. Only the thing is R12 and here it is R21. R12 of course is equal to minus of R21. Okay. So what we are having, the final conclusion, F12 I can write is equal to minus of F21. Okay, na? So if we consider the direction, okay, then F12 is equal to minus of F21. But in mod both the value are same. So what the force of interaction acting here and will be same. Yani F12 force acting on 1 because of 2 will be equal to F21 force acting on 2 because of 1. So this is the Coulomb's law in vector form, right? You can note it down. Okay, now we shall discuss relative electrical permittivity. So here let me write relative electrical permittivity. Right. Relative electrical permittivity or dielectric constant. Dielectric constant. Right. Both convey the same meaning. Actually, relative electrical permittivity only is called dielectric constant. And now what is dielectric constant or relative electrical permittivity? See, it is defined as the ratio of absolute electrical permittivity of a medium and absolute electrical permittivity of air or free space or vacuum, right? And it is denoted by K, capital K, right, or epsilon R. that is K, capital K everyone, epsilon R is equal to epsilon upon epsilon naught, right? Of course this also capital K is equal to epsilon upon epsilon naught. So this one is this epsilon is absolute electrical permittivity of medium, and this epsilon naught is absolute electrical permittivity of air or vacuum, what you call. So here epsilon R is equal to, which is actually a dielectric constant of that medium. Epsilon R is relative electrical permittivity of this. So relative electrical permittivity is equal to absolute electrical permittivity of medium divided by absolute electrical permittivity of free space, air or vacuum. Always do remember everyone, this is very important, and while solving numerical it will help you, right? Now see, let us deal. So for that, let me consider, let 2 point charge, let 2 point charge Q1 and Q2 are placed in air. First let me consider in air by r distance apart, then what is the force of interaction, I mean Coulomb force acting between these 2 point charge when placed in air? So that will F naught. If you do consider it by F naught, then F naught is equal to 1 by 4 pi epsilon naught. Easily I can write, okay, Q1 into Q2 by R square. No problem. I am writing in scalar form, not in vector form. Okay. Again, also, if the same charge separated in same distance are placed in a medium, right? In a medium other than free space or vacuum, then what I will write? F medium is equal to 1 by 4 pi epsilon, only epsilon. Remember, absolute electrical permittivity of medium is equal into Q1 into Q2 by R square. I will write now Q1 into Q2 by R square, taking these two equation. So using equation first and second, using equation first and second, what I can write? F naught upon F medium is equal to, see this one, this Q1 Q2, so this one will be cut na, and this 4 pi will be cut. So 1 upon epsilon naught divided by 1 upon epsilon. So what we are having left with? Epsilon upon epsilon naught. See, and this we call it K, capital K or epsilon R. Okay, let now fill it. This is what you call dielectric constant of the medium or relative electrical permittivity, which is nothing but a ratio of absolute electrical permittivity of medium to that of air or vacuum or free space. Okay, now this one, dielectric constant, can also be defined in terms of force, right? In terms of electrostatic, ratio of electrostatic force acting in between any 2 point charge when placed in air, is the force of interaction or is the electrostatic force acting in between same point charge separated by same distance in a medium. Yani F naught by Fm is equal to epsilon by epsilon naught is equal to K. Remember, this K is capital K or epsilon R. right? So K or epsilon R is equal to epsilon by epsilon naught. So from here one more relation we can get, epsilon is equal to epsilon naught epsilon R. This is one of the relation. Okay, now check it. Dielectric constant of some material जो है is there. So for example, I am taking water. Okay, so dielectric constant for water, what is the dielectric constant of water? What is the dielectric constant of water? I mean relative electrical permittivity of water, 80 to 81, 80.4. Okay, let me consider 80. Okay, let me rub first. See, one more thing I would like to add here. Suppose 2 point charge are placed in water, right? 2 point charge Q1 and Q2 say are separated by r distance and are placed in water. Then what is the force? What is the electrostatic force acting between these two? So when placed in water, I can write F force, electrostatic force in water is equal to 1 by 4 pi epsilon. I will write now into Q1 into Q2 by r square, right? Is equal to 1 by 4 pi epsilon. In place of epsilon I will write epsilon naught epsilon r, where this epsilon r is dielectric constant for water. Check out this list. 80. So I am going to place here 80. Okay, and let me see the result. What is the result coming? 1 by 4 pi epsilon naught into this value is 80, this value, and into I will write Q1 into Q2 by r square. So what I can write here, 1 by 80 I can take common now, and what we are having now, 1 by 4 pi epsilon naught I into Q1 into Q2 by r square. Now this value is what? This value is actually coming here, it is 1 by 80. This value is F naught when placed in air. This value is equal to the force, means the Coulomb force acting between 2 point charge when placed in air. So 1 by 80 times air. That means force जो है Coulomb's force acting between 2 point charge when placed in water is equal to 1 by 80 times of Coulomb's force when placed in air. That means force, electrostatic force in air is equal to 80 times electrostatic force when placed in water. See, here it is, everyone. We have one conclusion. The conclusion is, let me tell you, electrostatic force, here what I can say, looking this relation, I can say that this electrostatic force in air will always be greater than the electrostatic force in any medium, right now? That's all.